Hi, I am Varun Joshi and welcome to day 43 of our Certified Kubernetes Administrator 2025 course. Today we will explore Helm. We will learn how to create Helm charts, templatize manifests, manage releases, and simulate real world environments like dev, stage, and prod. This session will give you a solid foundation to work with Helm in both exam and in production. So let's get started. What you see on screen might look familiar to you if you have watched the previous lecture on Kustomize. With Helm, we are trying to fix the same challenges that we were fixing in the previous lecture, but Helm gives you a lot more power than Kustomize. And in today's lecture, I'll try to dissect what those powers are and how to appropriately use them. So what you see on screen is an application one. That application has three environments. It has a dev, stage, and then a prod. Each environment has three tiers: a front end, a back end, and a database. And all of these tiers are using few of the Kubernetes objects. Right at this stage, I want you to understand that the application that you will be dealing with might use more resources than you see on screen. So do not limit your imagination. Applications are subjective. If you are dealing with a security heavy application, then you would be using network policies. You could also be using custom resources that were created because you are using Kyverno, OPA, or any other security tooling. And modern applications also make use of cluster roles, cluster role bindings, role bindings, and there are many more objects. So I want you to understand that this list is indicative, it is not exhaustive. Then what you see here is a simple three tier architecture, and each tier is independent of each other. What I'm saying is, if I want to scale backend, then I can scale backend without disturbing the data tier or the front end tier. Similarly, if I want to scale front end, I can scale the front end without disturbing the backend and the database. They are decoupled, but I also want you to understand that if my front end is down, then my backend is of no use. If my DB is down, then my backend is of no use. So in that sense, these tiers are related, because if any of these tiers are down, then application will not function properly. Secondly, I want to mention that this is a three-tier design. You may also see that your front end has multiple microservices, your backend has multiple microservices, because microservices lets you decouple your environment. And if you have any confusions pertaining to this, I would suggest you watch day 11. In day 11, we learned about the three tier architecture and why this architecture exists to begin with. Then we also learned in this lecture that what are the programming languages that you would often see in these tiers. We also discussed about middleware, which is an important component when I talk about modern cloud native applications. And then finally, we closed this lecture by discussing about microservices and how they improve the overall architecture of your application, and also impacts how you can deploy your application in a highly available fashion. So let's go back to day 43 again. And if these tiers had microservices, then you would see more manifests, because each microservice will typically be using the same amount of Kubernetes resources. So for now, let's just stick to a plain three-tier architecture, no microservices here. Each environment is using 12 Kubernetes resources, and these three environments are using 36 Kubernetes resources. Now your manager comes to you and tells you to add a label in all of the Kubernetes resources. And mind you, this is a steep task because you will have to modify 36 manifests. Now, some of you might be saying, but Varun, what I have done is I have a single YAML and I have added all those objects in the single YAML itself. But how will you search that manifest? As your application grows, you will have to go to a certain section and modify a few things. Using Control F, Command F for searching will overwhelm you sooner or later. So this is one problem. If I want to add labels, okay, let's say my team goes ahead and added those labels. But my problem is when humans are doing tasks, it is error prone because we could miss something. But what we are good at is automation. So we wanted some way via which we can perform changes at a single place, and then those changes will be reflected across our application. And labels is just one example. What if I want to add annotations? What if I want to change the image? And mind you, when I talk about stage and prod, they could be using a stable version of your application and development could be using the latest. So we must ensure that whatever workloads underneath use container images like stateful sets, daemon sets, deployments, and so on are using the correct image version. And if I am using multiple manifest files, I will have to go into each manifest and see what application version is being used. What if I had a way via which I can just refer a single file and it has details about all my application, and those details are the details that keeps on changing based on applications maturity, that is release cycles, or it could be changing because I'm adding a few things. So this was a problem, and I have just mentioned 2-3 problems, but if I scroll to the left, you see there are multiple challenges. Rollback if something goes wrong. If I upgraded my application, I wanted a way via which with a single click I can roll back. Now if you have watched the deployment lecture where we learned about rolling updates and rollbacks, and we learned when it comes to deployments, you could use the best practice of adding an annotation with change cause annotation, and then you can update your application and also you can roll back, and all that happened with a single click. But that single click was limited to your deployment. It didn't understand your application as a whole, because your application is not just using deployment, it is using service, it is using config map, service account, and so on. I wanted a way via which I can do the same for my entire application. My application should be updated with a single click, and my application should be rolled back if something goes wrong with a single click. So we wanted a way what natively Kubernetes did for deployments. We wanted something for our entire application stack. Third is add labels for observability or compliance, inject new annotation, change image version for a patch release or rollback, modifying naming conventions, because we all know, if you have been following along this course, you know how particular I am about nomenclature. I want, if I see an object, I should be able to identify the application, the environment, and the role that entity is playing. What if you are working in an environment that does not adhere to proper nomenclature, and now you want a proper nomenclature? For that, you cannot be visiting all the manifests, because I, as an architect, want all the components of my application using the name of the application as a prefix, and maybe the environment as a suffix. Environment could be dev, prod, or stage, and so on. I cannot do that manually. I can, but that's cumbersome and error prone. Adjust replica counts or resource limits. And these are just a few challenges. I'm sure most of you are thinking about more challenges that you have been facing right now if you are dealing with multiple manifests. Now, what is the answer for this? The answer for this is Helm. Helm solves all these challenges, and it solves them bit by bit, inch by inch. Now, you might be wondering, Varun, you mentioned the same things in the previous lecture. The challenges were the same. What is different in Helm than Kustomize? So let's see this. If I scroll to the right, I have Helm versus Kustomize. When I talk about Kustomize, there was no life cycle tracking. It was not tracking your deployments as releases. But in Helm, all application implementations can be tracked as releases, and then releases will have versions to track on which version your application is running. That Kustomize didn't provide. Kustomize didn't have a rollback support with a single click. It was still manual, no upgrade logic. When we were dealing with Kustomize, we were reapplying the updated overlays. No version history was kept. In Helm, you have a version history. There is no templating. Kustomize doesn't support if range or variable in the way Helm's Go templates do. We have variable support in Helm, which is much more powerful than just plain overlays. No packaging or distribution. With Helm, what you can do is you can package your application as one, and then you can distribute it. Anyone else who wants to use your charts can use those charts. Now, these terms, charts, variables, Helm specific terms, do not get overwhelmed. We will look at them line by line as we progress with this lecture. Helm has something called hooks and post install guidance. Helm supports lifecycle hooks and notes via notes.txt, and Kustomize didn't have this. So these features are exclusive to Helm. Now, which tool you should be using? Again, it depends on your application and what all features you want to use. If your application is, let's say, simple, and again, simple is also a subjective term, but if your environment is using 20-30 Kubernetes resources, and those resources are not that YAML heavy, then I would suggest you can go with Kustomize. But if you want to use certain features, like if you have a stateful application or even a stateless application on your Kubernetes cluster, and you want a feature which will trigger something before the update, then Helm is the way to go, because Helm supports something called hooks. Maybe before the upgrade happens, I want my database, which is, let's say, external Amazon RDS, that gets backed up. Because Helm supports hooks, you can use those things in Helm. And there are many more features that are exclusive to Helm. Helm supports conditionals. It has named templates and so many other features, and some of those features we will discuss as we progress with this lecture. So now let's move to the next section. What is Helm? Helm is a package manager for Kubernetes applications. If you have worked with Debian, let's say Ubuntu, then you would have used apt, and apt is a package manager that will install a package along with all its dependencies, and can also help you upgrade that package or maybe remove that package. So apt is a package manager for Ubuntu. If I am on Mac, I'm using Homebrew, and if I run brew install this, it will install that. If I run brew uninstall something, it will uninstall that. And similarly, if I want to upgrade something, I will write brew upgrade and then the application that I want to upgrade, and it will do the task. And Helm is similar. If I run Helm install, it will install my application. Helm upgrade will upgrade my application. Rollback will roll it back. Uninstall will uninstall. And I can distribute my application. Hence, Helm can be thought of as a package manager for your Kubernetes applications. Any application that is deployed onto Kubernetes. You can use Helm to deploy your own custom applications, and we will do this in the demo section. We have 3 demos wherein we will be deploying our own custom application. We will be writing the Helm chart from the very scratch. Secondly, third-party tools like Prometheus, Grafana, Cert Manager, and there are plenty more. Why are these tools using Helm? I want you to understand that when I'm talking about Prometheus, Grafana, or any other tool that is using multiple Kubernetes resources, it is difficult for us humans to create all these resources manually, because there is always a chance for errors, and we don't want that. Hence, what you do is you package your application using Helm, because Helm is a package manager for applications that are supposed to be deployed onto Kubernetes. And then you use Helm install, and it will install all your application components, and you do not have to worry about what objects to create and what should be the settings for those objects, the configurations for those objects. Similarly, when I talk about complex tools like Prometheus, they all have their respective Helm charts, which allow you as an end user to just click and deploy that component. So if I have to deploy Prometheus onto my Kubernetes cluster, I will just use the Helm chart for Prometheus and deploy it. And in the previous lectures, we also learned about Kubernetes operators. And at that point of time, I also mentioned that operators themselves are deployed as Helm charts. So do not limit your imagination to think that it is only third-party applications like Prometheus, Grafana, and so on, Argo CD. They can only be deployed using Helm charts. You can create Helm charts for your own applications as well. The next point is Kubernetes doesn't actually understand your application, which is true. Kubernetes is a container orchestrator. If I scroll up, Kubernetes does not know that the service I have created is for application 1. The daemon set that I have created is for dev environment in application 1. Kubernetes does not know this config map belongs to the prod environment. Kubernetes is just creating resources and performing container orchestration. We wanted a tool that will understand my application as a whole. And if that tool understands my application, it will also understand what are the Kubernetes resources that are being used by my application. That tool would know that if it is the dev environment, then all these resources belong to the dev environment. And Helm does exactly the same, because it understands your application as a whole. It considers your application as a single package. It can help you upgrade it, install it, or even uninstall it. The next one is installing Helm. Installing Helm is simple. I mean, if you go to the GitHub notes, and if I scroll down, I have a separate section where you will find instructions on how to install Helm. It's a simple install. If I go to this website, here is how you can install Helm, and you can find this in the GitHub repository. So I have already installed Helm in my system, and you can also do the same. So I'll go back to the diagrams now. Now I want to discuss the core components of Helm. The first is a chart, second there is a repository, and then there is a release. And I want to throw an analogy at you right at this time. Image registry, I want you to think of a repository as image registry, because image registry is a place where container images are stored. Similarly, a repository is a place where you store your charts. Then there is a running container, and similarly, this release is a running instance of your chart. So in one line, chart defines the blueprint of your application. Repository is a place where you can store and manage your charts. Then release is a running instance of your chart. Similarly, if I talk about the container world, then container image is the blueprint of your application. Then image registry is a place where you can store multiple container images. And then what is a container? Container is a running instance of a container image. I hope this analogy will help you understand the core components of Helm. Hierarchy is repository contains charts. Charts are installed as releases, and we will look into it in detail now. Chart, it contains everything you need to deploy an application. Includes templates, values, and metadata like a config bundle. And we will see the directory structure of Helm to familiarize ourselves with this point. Reusable versioned blueprint of your application. So this is an important point. Reusable, and we will see how a chart is reusable, as you can use the same chart to create multiple environments. So one chart can be used to create dev, stage, and prod environments. That's so good, and we will see that in demo 3. Then last is can be shared via chart repositories or reused across environments. And reused point, we will see it's same as this one. Repository stores and shared versioned Helm charts. That's understood. You can add multiple repos and search across them, and we'll see this right after this session. Popular ones include Bitnami, TrueCharts, Grafana. Now there are plenty of repositories when it comes to Helm, and it becomes really difficult to search each repository. So what you can do is you can directly search the artifacthub.io, which can be thought of as culmination of most of the popular repositories. So if you want to search a chart, maybe you want to see whether there is a chart for Nginx somewhere, then you can also search the artifacthub.io, and you can do that via the CLI itself, and we'll see this in the next section. Use Helm repo add list search to interact with the repository. Then there is a release. A running instance of a chart in your cluster is a release created with Helm install, then the release name. Each release has its own config history and state. I want you to understand that let's say you created a Helm chart and then you created application 1 release using that Helm chart, and we'll be dealing with app 1 itself in this lecture. You created an app release called app 1. Now there could be multiple versions of app 1, so you could be dealing with version 1 now, then version 2, then 3, 4, and so on. Helm keeps track of this if you are using Helm to upgrade your application. For example, when I talk about release, underneath release you have something called revisions, and each revision is a snapshot of your application at a certain time. For example, version 1 of app 1 could be associated with revision 1, version 2 could be associated with revision 2, and so on. And we'll see this in the demo section as well. Can be upgraded, rolled back, or uninstalled. We already know about this. Same chart can be installed multiple times as different releases. App 1 dev, app 1 prod, etc. And we'll see exactly this in our demo 3. And again, I want to mention one more point here. When you are upgrading or rolling back, especially when you are rolling back, you will be supplying the revision. So there is a release, and a release can have multiple revisions. Without wasting any time, let's directly go to the CLI and practice a few things. So I will go to my terminal. I am in day 43. Day 43 should have 3 directories. Yeah, demo 1, 2, and 3. So right now, I want to give you a CLI walkthrough of common Helm commands. So firstly, Helm version you can use to check the version of your Helm. I have 3.18.3, and then I can use Helm-H to see what all are my available options. And repo is the one that we are going to use for now. And understand, using -h is extremely important. You do not have to search the web whenever you are stuck somewhere, because this is quite intuitive. If I write Helm repo, I can just add -h and it will tell me what you want to do. Do you want to add a repo, index, list, remove, or update? And these 5 you will be using all the time. So right now, let's do one thing. Let's add a repository. So I will write Helm repo add, and then I have to supply the name of the repository. And before I supply the name, I will also have to name this repository. Now what I am doing is, typically what people do is they add Bitnami here and then they add the repository. Bitnami is a popular repository for Helm charts, and you would often see that popular charts like Prometheus, Grafana, all of these are hosted in this repository itself. But again, if you are dealing with EKS, Amazon EKS, Elastic Kubernetes Service, then you would see some of their Helm charts are hosted in their own repository. So there is nothing written in stone. Whatever tool you are dealing with, that tool provider will be telling you that if you want to deploy our application with Helm charts, then this is the repository that you should be adding. So this will be given to you. Now I write Helm repo add Bitnami, but I typically always prefer to not use these kind of names. I always add the project name, or in this scenario, I will add just my here, so that when I look at this, I know this is something that I created. This was not there by default. So I want whatever nomenclature I am using is specific to the project, so that if I look at something, I know right away that this belongs to this project. And again, this becomes extremely important because your Kubernetes cluster will not just be holding one application. You could be hosting 20, 30 multiple applications in your Kubernetes cluster. Hence, I'm stressing on this point. Be extra careful with how you name things. I will press enter and it says my Bitnami already exists with the same name configuration, so it is skipping. I did this while practicing for this lecture. Now let's write Helm repo list, and this will tell me there are 2 repositories part of your Helm implementation. This one was created by default. Now let's do another thing. Helm repo remove, and then I can also remove this like this. And then we can add this again with the same command. I hope this is clear. Now let's search this repository. What I can do is I can just write Helm search repo, and then which repository I want to search. I want to search the repository I just added, my Bitnami. So I'll write my Bitnami and press enter. So it will show me all the packages that are available in the Bitnami repository, and there are plenty of them. So what I can also do here is I can now be specific with my search. I will say Helm search repo my Bitnami, and here I want you to grep Nginx, and if I press enter, it will tell me everything related to Nginx that is available in this repository. You see, if you want to deploy Nginx web server, then you could be using this one, and it has the latest Nginx version, which is 1.29, I believe. 1.29 is the latest. And then it has listed everything related to Nginx. First, you see the web server Nginx. Then there is Nginx ingress controller, because we know Nginx is not just a web server. Nginx can be used as a caching solution, as an ingress controller, and there are a few bells and whistles that are associated with Nginx. Then there is Nginx Intel. This is deprecated. I'm not sure what this is. So you can use this search feature and you can grep for something specific. And let's see, I told you Prometheus is part of Bitnami. I think I should check that, because I'm not sure that's true, because Prometheus could have their own Helm chart. Yeah, you see, Prometheus is also available in Bitnami repository. Now this is fine, Varun, but what if I want to search this one, artifact hub.io? This is, I told you, where this can be thought of as a culmination of all the repositories. So if I copy this thing and I go to the browser, and then I will paste this here and press enter, and you can see this is hosting 17,675 packages and these many releases. So you can also search whatever you are searching here. If I write Nginx here, then it will show me the Nginx, and this one is again in the Bitnami repository. So once you start browsing it, you will understand more. But whenever you are dealing with a specific tool, let's say, when I say specific tool, as in you are paying for that tool, then they will guide you on which repository to use and how to do the installation and how to use their Helm charts. But when you are dealing with open source tools, then this is the place that you would be visiting to see whether there is a chart for that and how to use that chart. So if I click on this, this will also give me on how to install this chart and then how to use this chart. Then what I will do is I'll go back to my terminal, and here I will show you how to search this artifact hub using the CLI. So I will write Helm search. Previously we provided a repo and the name of that repository, and I want to tell you one more thing. When you run Helm search repo my Bitnami, this is not going to the internet for this search. This is the local search that is happening, because we first added the repository, and you saw when I added the repository, it took some time. So it was maybe adding the indexes. So if you search that repository, it is not going to the internet. It is happening locally itself. So I will now search the Helm search hub. I want to search artifact hub.io, and then I will just write Nginx, and this will give me everything Nginx that is available in artifact hub.io. And you know, when we ran Nginx here, when we searched for Nginx, there were so many results, and there are 15 pages here, and you see all those results here as well. But if I want to, let's say, search for Nginx, and I want to grep for Bitnami, because I want Nginx that is available in the Bitnami repository. So I'll press enter, and this will again show me Nginx that is available in the Bitnami repo. And here you see there is a web server, and also there is Nginx controller. Now that we have this understanding, I quickly want to show you how to install, and we'll be looking this in detail, but I do not want to keep you hanging here. So let's do one thing. I will write Helm install. Okay, this is the syntax, Helm install, and if I press -h, then you can see what all are your available options, but at the top is how you use it. Helm install name. What is this name? this is the release name, because what we are doing is whenever you are installing something, you will always be using Helm chart for this. And whenever you run your application, that is called a release. And what is a release? Release is the running instance of your chart. So what I am saying here is Helm install, then I'll give the release name and what is the chart you want this release to be using, and then you will supply the chart name. As simple as that. So what we will do now is I'll first clear my screen so that you can see properly, and then I will write Helm install. I want to name this my nginx for now. And from where do you want to install this release, and which is the chart you want this release to use? And here I will simply say my Bitnami, because you remember we named it my Bitnami. Then I will add a forward slash and I will write nginx and I will press enter. And this will install nginx in my Kubernetes cluster, and it has done the installation and it is giving me some information about this release. And I will not be showing any other commands to you right now. I will park that for the demo section. And here, if I run kubectl get pods, you see there is a my nginx pod created. And since chart deploys something as a whole, if I run kubectl get all, you see that there is also a service created, and that service type is load balancer. But why is that? This is because understand that we have installed nginx web server, and nginx web server typically front ends your application. Hence, they also created a load balancer service for you. Hence, whenever you are installing nginx chart, what you see is a service created for you and also a deployment. Now, how do I uninstall this? I told you Helm is a package manager. It takes care of the entire life cycle. So what I can simply write is Helm uninstall. See, I'm not running any release specific commands, any revision specific commands for now. We will do all those things in the demo, but I just want you to have a basic gist of Helm, like how you install something and then how you remove something. And now we are uninstalling, and I will simply write my nginx and I press enter. Voila, it is done. If I now run the same command again, kubectl get all, I do not see any resources. So that's with the CLI walkthrough. Now let's do one thing. I want to show you one more thing. I'll clear my screen. Now let's create a Helm chart. So I will simply write Helm create my chart. In this section, we will be discussing the directory structure of Helm. So what this command will do is it will create a basic directory structure for you, and you can use that structure for your custom application as well. And we are using right now this for learning, and then in demo 1 we will be using the same structure to deploy application 1. So now let's write our command, that is tree. If I press enter, this will show me everything. So let's do one thing. Let's clear this. I'll type ls, and you see when I ran Helm create my chart, my chart is created here. So if I run tree my chart and press enter, this is the directory structure. All these are created for you, 4 directories and 10 files. Now let's do one thing. Let's go to the GitHub notes to understand what these things are and how they are relevant. So I have the same chart structure here for easier understanding. So chart.yaml, notice the uppercase C, and it is chart.yaml. this holds the metadata about your chart, so name, version, description, and it also has the application version, and we will see how important that is when we will perform upgrades and rollbacks. So this field is required. Then you have values.yaml. V is lowercase here, and this is the place where you will have all your modifications. So if you have learned about Kustomize in the previous lecture, then this is similar to how customization.yaml is in Kustomize. Here you will store all your modifications. So let's say if you are dealing with this environment and you are using a single chart to deploy all these environments, then it is the values.yaml where you will be storing all your modifications. So keep that in mind. Then you have templates, contains all your manifest files. These are YAML files with Go templating supports, and these are also required. Now understand that when you are implementing an application, that application will require multiple objects, and all of those YAMLs are stored. All of these YAMLs will be stored in the templates directory. And if you see the sample directory structure that Helm has created for us, you see there are multiple YAMLs that are typically used by an application. You can see they have already pre-created them for you. And I would highly recommend you go to these YAMLs and see what all information is there, what kind of templating they have used. We will be seeing that, but after you are done with this lecture, then do visit this. Then I have charts. It holds chart dependencies. For example, if your chart is dependent on something, then you would have that something stored in charts. So for example, if your chart depends on another chart, then that information is stored in this charts directory. Then I want to discuss -helpers.tpl, helper templates that can be reused across your YAMLs, optional for dry templating. Dry is do not repeat yourself, and that is what templating will do for us. Then we have notes.txt, post install message shown after Helm install, example output app URLs, credentials, etc. And then tests is where you will have your hooks, optional for writing Helm test jobs. Now this is the basic structure that will always be there for you, and there are fields, there are files and directories that are required, and then there are some optional stuff. I want you to know that the major part for this is chart.yaml, then templates, because this is where you will be storing all your YAMLs, and then values.yaml. So once you have your chart up and running and everything is smooth, then you will predominantly be only be playing with values.yaml, and whatever modifications you need you will do here. And then whenever you deploy your applications, all the values that these manifest will be using will be picked from values.yaml. And let's see now how that works. So I want to move to demo 1 now. If I scroll down, demo 1, so we'll be writing our own Helm chart from scratch. So let's go to Visual Studio Code. Again, I will go to demo 1, and you see, if let me cd into demo 1 so that I can show you the tree command. I will cd into demo 1 here, and then I'll clear my screen. I will write tree here, and we see the same structure, but I have removed the things that we do not need. I have a chart.yaml, I have charts, I have templates, and since we'll be dealing with an Nginx deployment and an Nginx service of type node port, hence I only have 2 YAMLs here. The concepts will remain same even if you have multiple YAMLs. Then there is values.yaml where I will store all my modifications. Now let's go to Visual Studio Code and see what is happening here. I will first go to chart.yaml. Now I want you to concentrate on this version and this version. This is your chart version and this is your application version. Now your application version will be changing as you upgrade your application. For example, if right now I am using a container image that is of Nginx 1.22, then my app version will be this. If I choose to upgrade my application, then I will change this app version to 1.23, and also my deployments will be using the new image that is Nginx 1.23. And in demo 2 we will be seeing how you upgrade an application when you are using Helm. Then you have a version field. This version is the chart version itself. So when you change, let's say, something in the chart configuration, so you added a few labels. Now adding a labels is not impacting your application because your application for the end users is behaving the same. So adding labels, adding annotations, adding requests and limits, this is specific to infrastructure tasks. Hence, whenever you do things like this, adding label, removing labels, adding annotations and so on, then you will be changing this version because essentially you are upgrading that chart. App version goes in conjunction with your application, and typically you would see you will write the application version here. And then there are few other fields which are self-explanatory, and I will let you read about them. And this is an important field. API version is v2. There was previously Helm 2 and we have Helm 3 now. Helm 3 was released in 2019, I believe, and we use Helm 3 now, which is why we have version 2. Helm 3 is associated with API version v2. And at this stage, no one asks, even in interviews, what was Helm 2, how it is different than Helm 3. So Helm 3 is the way to go now, because back in 2020, 2021, there were a lot of interview questions about Helm 2 and Helm 3, their comparison. But nowadays, everyone is using Helm 3. So there are no questions that I've seen recently being asked about, what are the differences between Helm 2 and Helm 3. So you can park that for now. But yeah, so this is the description. That's fine. And then let's see what all we have in our templates. So you have deploy.yaml here. And this is a plain YAML that we have been dealing with. It just has a few new fields. That's it. Rest everything is fine. But first, let's talk about the first thing that is new to you, that is the name field. So what I am saying here is, if you look at this syntax, this is the Go templating syntax. You have space at the front and then you have space at the last. Dot release dot name. This is a built-in variable when I talk about Helm. So what I am saying is, I want you to name your deployment with my release name and then add this to it. So what will happen in actuality is, let's say if I name my release app1, then my deployment will be called app1 - this. And then if I go to browser, then if I scroll down, so if you see here, there is a release object that has multiple variables. Then there is dot chart and then there is capabilities. So if you write release name somewhere, then it will have the release name. If you have a release revision, then it will add the release revision. And similarly for chart, you can have chart name, chart version, chart app version. And as we progress with this lecture, you will understand most of these things. Now I'll go back. So what I have done here is, I have templatized the name of my deployment, and which will make my life easier, because whenever a resulting deployment is created, it will have my release name, and my release name will be app1, and I can easily identify that this deployment belongs to app1 and app1's functionality that this is doing is it is an nginx deploy. This is my front end. So this nomenclature looks good to me at this stage. I'm also templatizing replicas. What I'm saying is dot values. Now dot values is not something that is built in. This is what we can specify ourselves. Now if I look at replica count, you see R is lowercase here, but here N is uppercase because these are built in. You do not have that flexibility. So if I go to my browser again, you can see that you control this. These are values are user defined inputs. Now, if I go back here, I am saying go to values. Values is values.yaml, and I want you to check the replica count, and whatever I have defined there will be the replicas required by this application. Here I am saying go to values dot image dot repository, and there you will find the repo name, and then I'm saying colon because I also want to have a tag. So if here you write image and then you have nginx, and then you write the version of nginx that you want to use. We are using the same here. We are saying for this part you go to values.image.repository, and there you will find it, the name that has to be filled here. And then what is the tag? If you want to find the tag, you go to values image, this part is same, and then you will see a tag here. I hope that's understood. Now let me do one thing. Let me open values.yaml for you. I will open this, and then I will split this to right, and then I will close this one. I will go to, I'll just do this, and then I will go to view, and I will also word wrap this. Okay. Now let's see what is happening in values.yaml. There is no specific format for this. You can call this anything, but we want to call this with a name that is self-explanatory for us, so that not just we, anyone who watches our work can figure out what we were trying to do. So I have added a replica count here. So what I'm saying here is replicas go to replica count, and this is replica count. Hence one will be filled here. In here I'm saying values images repository values, and this image is a dictionary here. Values dot image, this is dot image, then repository, and what you see in repository nginx. So this, the resulting value would be nginx. So understand that I am templatizing these things. I have templatized 3 things, and the values for those things can be found in values.yaml. That's the only concept here. And then what I'm saying is value image tag is this one 1.22. I hope this is understood. Now let's do one thing. Now let's go to the terminal. I'll go to the terminal, and I will first run ls. We have app1 hyphen chart, and that is what we created. If you remember, in the previous section we created my chart. Here I have named my chart app1 chart, and I like to add as a suffix whatever I'm creating. If I'm creating a chart, I typically would name it app1 chart. Now what I will do is I want to verify that my YAMLs are correct and Kubernetes will accept them. So what I will write now is I will write Helm lint, the name of my charts directory. Now what will lint do is lint will verify my YAML syntax. So if I press enter, it is saying 1 chart linted, 0 charts failed. So everything is fine. Now you can also disrupt this. So what I can do is let's open our service YAML for now. And I forgot to open the service YAML in the previous part. But here what we are doing is we are doing the same thing. We are just templatizing the name. We are saying here I want you to fill the release name. And we know a release name is a built-in variable. When we install this application, we will configure a release name, and that will be appended here, that will be prefixed here. So now let's do one thing. Let's disturb the indentation. So what I will do is I will add a space here, let's say. Okay, this has disturbed the indentation, this is not a correct YAML. So I'll go here and then I will press enter, and it says that chart unable to parse YAML, error converting YAML to JSON, line 11 has a problem. So here we know that we added that space, so let's remove it. So now error is fixed. So it is not verifying your Kubernetes manifests, okay? It is just verifying the YAML syntax, simple and plain. Now I also want a command that will check how my templating is working, right? So what I can write is I will write Helm template, and then again the same format. I'll enter the directory of my chart, and this is app1 hyphen chart, and I'll press enter, and this is showing the template. But what I'm seeing a release name here. Why is this release name? I should see the actual release name, but I have not yet created a release. So what you can do is you can add app1 here. Adding this will tell this Helm template command that when a release will be created, it will be named app1. So show me the results accordingly. Now if I press enter now, it now shows me how the values will be rendered. You see image is nginx 1.22, you see replicas are 1, and you see the name is app1 hyphen nginx hyphen deploy. If I scroll up, the service also has the same name, but it has a svc as suffix. This looks good to me, but Varun, let's do some chaos engineering. We want to see how this will throw an error if something is not right. Now let's do one thing. Let's again go to our Visual Studio Code. Let's remove this thing. So now we are not adhering to the Go templating standards, and let's rerun this command, and it says error, parse error at this unexpected hyphen in operand. So this is fine, but it is also giving me another important information. It is saying use hyphen hyphen debug flag to render out invalid YAML. So let's do that. I will add hyphen hyphen debug here. If I press enter, it is exactly showing me what my error is. Now I can go here and then I can fix that error. It told me that line 4 has some problem, and I have fixed that. Now let's run this again. Debug. It will not throw any error because we do not have any errors now. I want to install the application, but let's do one thing. I will write Helm install. I will write app1, that is the release name I want to give this, and then I will add my chart directory. Now remember, previously we were providing my bitnami / nginx because we were using a chart that was part of a repository that we added, but this time we have created our own chart that is stored locally, hence we just have to provide that chart, rest everything will be done. But here is the chart directory. We have called it app1 chart so that we clearly know where we are running our commands. And I will write this, and then I will do one more thing here. What I will do is I will write dry run here. Now what is dry run doing? It renders templates and simulates a Helm release install without touching the cluster. So cluster is not touched yet. Now let's remove this dry run flag and I will press enter. Voila. Name is app1, last deployed it is today's time, Thursday 10th 8 o'clock, namespace default, status deployed, revision 1, test suite none. Now let's run Helm list. Now Helm list is a command that will list all your releases. I will press enter. I only have app1 which is in revision 1. So the right now the revision of this release is revision 1. Status is deployed. Now here is the part. When you run Helm list, you want this to represent your chart version and app version. So ideally your application version and this should be same. So whenever you are upgrading your application, ensure you edit your chart.yaml which has C in uppercase. Now let's run Helm status app1. This will show me the status. This is the same output that we received when we created this release. Now I want to run a command that will show me the revisions. So I will write Helm history and understand if I want to check what all revisions have been in my release, I will have to check the history of this release. So this command is quite intuitive. I will write Helm history. I want the history for app1 release. If I press enter, it shows there is only one revision, and then it also shows me the time for it. The version and description is install complete, and we'll pay attention to this description because this will change when we are doing rollbacks. So let's now run kubectl get pods, and you see there is app1 nginx deploy in running state. And if I also add svc here, then you see app1 nginx service is also created, and there is a node port automatically assigned to it because we did not statically define the node port. Now let's do one thing. We have installed our application. Now I want to show you the power of Helm. Okay, I wrote Helm list. Now let's say a user said to you that, to the application owner, that I am facing some problem with this version of application. Can you look at it? Now I cannot do the changes in this particular release because this release is running in production right now and I do not want to disturb it. What I want to do is I want to create a parallel infrastructure and look at the problem from there. With Helm, you can do that with a single click. Imagine if you didn't have Helm at this stage, then you will have to deploy all those resources, all those YAMLs in that namespace, and also take care of the naming, because two things cannot exist with the same name. That is not possible. If you want to replicate production, you already have a development and staging, but you want to quickly do some testing in the actual production, you will have to recreate it entirely, and that requires a lot of rework. With Helm, what I will do is I will write Helm, and then I will write install, and then I will write app1, but I will call this test, and I will mention the same chart. I'll press enter, and if I run Helm list, it has created a release for my testing. If I run kubectl get pods, I see there is a pod created with app1 test. I want you to notice one thing. If I go to my Visual Studio Code, I have templatized my names here, which is why I can easily identify to which release this application component belongs to. Here I can clearly say, oh, app1 test, this belongs to a Helm release named app1-test, because that is how I have defined it. Now imagine if you hadn't templatized this part or this part in your deployment, then this command would have threw an error to you, the Helm command, because it would have created a deployment with this name, and if you would run that command again, it would say that deployment already exists. Hence you will always see, when you are dealing with real production scenarios, the name is always templatized no matter what. And here I have only templatized these things. In future demo we'll also templatize this, but I want you to know that you can templatize anything that changes in your environment. You have multiple options. So keep your imagination open when you're working with Helm or DevOps in general. Now this is done. Let's do one thing. I will uninstall the test release. I will run kubectl uninstall app1 hyphen test. I'll press enter. Oh, it's not kubectl Varun, it's Helm. I'll write Helm and I'll press enter and it says uninstalled. If I write Helm list, I see only app1 release is present in my cluster. Now let's move to demo 2. In demo 2, I want to show you Helm upgrade and rollback in action. So we have been using Nginx 1.22. We will be upgrading this to Nginx 1.23. After the upgrade, let's say there was an issue reported, and then we will roll back to 1.22. And this is the exact workflow that you will be dealing in production. It is just you will be dealing with multiple manifests, but again, you would have templatized most of those things and you will only have to concentrate on values.yaml. That is where you will have to perform the changes. Rest everything will be taken care by our dear friend Helm. So let's go back to Visual Studio Code. Now what I will do here is I will just copy app1-chart and then I will paste that here in demo2's directory because I don't want to perform multiple changes. I'll close this, I'll close this, I'll close this. I will minimize this. I want to deal with demo 2 right now, and then the first thing I want to edit is chart.yaml with uppercase C. Now I want you to clearly understand, I am not updating the chart. I am upgrading the app. I'm not adding any labels. I'm not doing anything as such. I'm just upgrading Nginx from 1.22 to 1.23. So I will not change any of this. I will not change this. I will change this. I will change this to 1.23 so that when I upgrade my application, the app version in Helm also denotes 1.23. Then I will go to values.yaml because I have templatized my image versions. I do not have to go to my Helm templates. I do not have to edit my YAMLs. I will just edit values.yaml and my application will be upgraded. So I will write 1.23 here. I'll save this. Then I will go to the terminal. I will cd back. I will cd into demo 2 and then here I will ls. I see that app1 chart 3 app1 just to be sure everything is intact. I will just run the template command again, kubectl template app1 and then it is app1 chart. I'll press enter. I have to write Helm, not kubectl. I'll press enter and you see it is Nginx 1.23 and replica is 1. We didn't change anything else. We just changed the image version and that is 1.23 now. That part is fine. If I run Helm list, I still see app1 is on revision 1. So let's write the upgrade command now. I will write Helm upgrade and then I will write here Helm upgrade app1. This is the release I want to upgrade and the chart I want to use is this one, app1 chart. I'll press enter and you see revision 2 and the time. And if I now run Helm list, I will see the same output, but it will have revision 2 now. And the time at the point when revision 2 was deployed, app version is 1.23 now because we changed this, and chart version is app1 chart 0.1.0. Since we did not change anything that was chart specific, we left the version as is, but application was upgraded, hence I have that here. And now what I will run is I will run Helm history app1. I'll press enter and you see there is revision 1, that is this one, 1.22 app version, and then there is revision which is using nginx 1.23, and I can run kubectl get deploy -o wide, and I press enter. I see my image being used is also 1.23, and it was updated 12 minutes ago. The age of the pod is 12 minutes. Now let's do a rollback. Let's say user said that 1.23 is giving some unexpected result, so you as a DevOps engineer had to roll it back. So now let's see, how do you roll it back? I will write Helm. Previously I wrote upgrade. You see here, this was the command for upgrade. This time I'm rolling back, so I will write rollback, and then I want to roll back app1. To which revision do you want to roll it back? I want to roll it back to revision 1. I will press enter. Voila, rollback was a success. Happy helming. And then let me write that helm history app1 command again. If I now press enter, did you notice one thing? Even rollback creates a new revision, that is revision 3. So Helm maintains a complete timeline of changes. And if you look at the description section, it clearly says that rollback to 1, and the app version has also changed to 1.22 like it was in revision 1, and the status is deployed. So you see, with a single command, we upgraded our application, and with a single command, we rolled it back. And guys, that is the beauty of Helm. Since it is maintaining multiple revisions, you just mention, I want to go back to this revision, and it will take you. This feature was not there with Kustomize. You could not tell that I want to go back to this revision. That functionality wasn't there. Although you could just simply change the image version in the manifest and do and apply again. But this is a little more simpler. I also want to show you kubectl get deploy -o wide, and you see this is now running nginx 1.22, which is what we expect because we rolled it back to revision 1, but this is now called revision 3. And why is that? Because Helm maintains a complete timeline of changes. You see, roll back to 1. Now let's do one thing. Let's finish this demo. I'll clear my screen, and now let's move to demo 3, and let's see what are we going to do in demo 3. Multi-environment deployments. In this demo, we will simulate 3 production-like environments. You would often see dev, stage, and prod using the same Helm chart and separate values.yaml. Understand that Helm is looking for values.yaml, but if you are dealing with 3 different environments, then you must have 3 different values.yaml, because the replica count for prod environment and stage and dev would be different. Hence, you will have to specify replica count for each of those environments, and you cannot deal with a single values.yaml to do that. So you would need 3 values.yaml for each environment. So let's go to the CLI and do these things. I will go to my Visual Studio Code. I will expand. I'll first minimize demo 2. I will expand demo 3. And before I move to demo 3, let's delete everything that there is related to this specific lecture. I will delete Helm, uninstall app1, Helm. Oh, I have to spell it right? And then I will run Helm list. If I run Helm list, I do not see anything. Now, since we are dealing with 3 environments, dev, stage, and prod, let's create namespaces for each of those environments. I will run kubectl create ns dev. I want the same for stage, and I want the same for prod. And if I run kubectl get ns, I see these 3 namespaces are created for me. Now let's go back to our dear friend Visual Studio Code. I already have the chart structure created for demo 3. So let me quickly close these. These are from demo 2. And now I will open charts.yaml. I am in demo 2. Sorry. Let me close this. I will open demo 3, and in demo 3 I want to open chart.yaml. I want you to understand one thing very clearly. We were dealing with a single environment before. So we were using this app version field to define what is our application version. But we are using three environments right now: dev, stage, and prod. And typically stage and prod will be running a stable version, and stage and prod will be same, and dev will be running the latest version of your application. Then Varun, if we are dealing with three environments, which app version should I specify here? This should always denote your production version. This creates a confusion for a lot of people, that how do I deal with this app version? So industry recommendation is to use the production version, so that when you are watching your Helm chart, you clearly know which version of my application is being run in production. So that part is clear. I have, what we will do is, we will, let me open values.yaml for you for dev, and what you see here is I have created rest. Everything pretty much is the same. So if I go to the terminal and I cd back, I will cd into demo 3 now. I will run a tree here, and you see rest is pretty much similar, if not same. But what I have done is I have created three values.yaml, one for dev, one for prod, one for stage. And you can name this anything, but do sensible naming. So I have named them -dev, -prod, -stage. So let's go and check what is happening in these YAMLs. So values dev, I want one replica in dev. I want this image to be in dev environment, that is 1.23. Namespace I have defined as dev. So if we go to the manifest, we will see we have templatized a few new fields. And similarly, if I go to stage, then the replica count is 2. Stage is running 1.22. Namespace is stage as expected. And if I go to prod, prod has namespace prod, tag is 1.22, and replica count is 3 in production. So 1 in dev, 2 in stage, 3 in prod. Replica count. And if I go to the YAMLs now, deploy.yaml, what I have done is, when you are dealing with these different environments, you know that you will be collecting logs and doing monitoring and all those things. So you want not only your pod names to be consistent, but you want your container names to be also representing the environment. The first templatization that I've done is I've added a namespace section, because we want dev environment to run in dev namespace, stage in stage, and prod in prod. So hence I've added this. And from where are we taking the values for this? If I open the dev manifest, I will open this, and then I will yeah, let's do this, and I will split this to right. I will close this one, and you see what I'm saying, namespace is dot values dot namespace. So go to values.yaml. Here is my values.yaml, and I will tell you how do you specify custom value files. Do not worry about that. I'm saying values dot namespace. Dot namespace is this, and the value is dev, so it will fill dev here. I hope that part is self-explanatory. And similarly, for the container section, I've changed the name of the container. Name of the container is release name -container, so that I know this container belongs to this environment. Now let's do one thing. Let's go back to our terminal and clear my screen. And then what I will do is I will start running the commands. We have already created the namespaces, but now let's run Helm lint, and then I will mention app1, which is already there, but I cannot just press enter, because if I press enter right now, it will give me an error because it cannot find values.yaml. It says values.yaml does not exist because it is not here. We will have to specify our custom file name, the values.yaml's new name, because we have 3 files now. So what I will do is I will go here, I will write -f, and where do you find that values.yaml? It is in the same charts directory and it is called values-dev.yaml. And now if I press enter, it says 1 chart linted, 0 chart failed, and that is what we expect. And if I press the up arrow, I can also run the other commands. I can write template here, and if I want to also specify the name of my release, then I can write app1-dev. We have been calling it app1 since the beginning, but I want my nomenclature to clearly reflect that this app1 is for the development environment. And if I now press enter, it has done the naming that way: app1-dev-nginx-deploy. This is picked from our manifest itself. And you see, since we are running dev, it is running 1.23 and our prod will be running 1.22. This is clear. And there is also a namespace section here which says create this in the dev namespace. Now let's run the install command. So I will press the up arrow again, and then I will go here. Instead of template, I will write Helm install. The release name I want is app1-dev. The chart is this -f. The file I want to refer for values is this one. And then what I will do is I will press enter. It is created. And then I will also do this for stage.yaml, and here also I will write stage, and then I will do it for the prod too. Now if I run Helm list, I get a list of all my releases. There is app1-dev, app1-prod, app1-stage. And if I run kubectl get all, if I now add -a, let's run get deploy. And if I press A, you see that my deployments are created in their respective namespaces. And that is what we expect because we have already defined the namespace in the metadata section. That is expected. But I want you to notice one thing very clearly. In the namespaces section of Helm, the namespace is default. Why is this? Think about it, because we specified the namespace here, so this part is understood, but this should also denote the correct namespace. Why is this showing default? Because if you do not provide the namespace in the install command, the Helm release tracking stays in the default namespace. You must specify the namespace in your manifest like we have done. And you should also specify the namespace that when you run this command, because that tells Helm that in which namespace your release is created. Helm knows where to track the releases. Humans and tools know what belongs to what. Now let's do one thing. I will run Helm uninstall, and right now it is not intuitive. If you see it, if I look at app1-dev, I do not know in which namespace this app1-dev is until and unless I run kubectl related commands. But I don't want to do that. I want everything that I need should be available in a single command, and it should represent the correct statistics. Right now it is not. So what I will do is I will uninstall app1-prod, dev, and stage. I've uninstalled everything. Now I want to run the same command again. This is the command, and now I will add -- namespace is equal to prod, since I'm dealing with prod right now. And I want to show this to you in GitHub notes as well. So if I go to demo 3, I have clearly mentioned this here as well. So do read about it, use namespace explicitly, and this is the command that you would be using when you have set the namespace. So let's go to the terminal and press enter. And now if I run Helm list, I see nothing, because Helm list by default shows you only the releases that are present in the default namespace. Now, since we have been following the best practice, if we type -a here, only then we will see this. And now we see app1 prod is in prod namespace. So let's quickly do this for rest of the namespaces as well and get our job done. I will also write stage here, and then I will come here, and here I will also write stage. I will press enter. So for stage we have done. Now I want to do the same for dev. I would be using the values.yaml associated with dev, and I want to name this release app1 dev. I will press enter, and this is also created. If I now run Helm list, I won't see anything. If I run just Helm list, I should add -a here, and this shows me that there are 3 releases. And even though we know dev and stage are running 1.23 of the application, we are not showing that, because as I told you, since you have a single chart.yaml, that YAML should represent the app version of your production application. And here you see I have also upgraded the chart version. Previously the chart version was 1. We are in 2 because we have made changes in our chart. We have added few more things. So if I go back to Visual Studio Code, we have added this, and then we have added namespace, which is why I have also upgraded the chart version if you compare it to our previous 2 demos. And now if I run kubectl get deploy -a, then you see there is a deployment in dev namespace, there is in prod, and then there is in stage. And I also want you to see that this has 1 pod dev, prod has 3 pods, and stage has 2 pods, like we defined in our values.yaml. And if I add a -o wide here, you can also see the nginx version. The prod and stage are using 1.22, which is what we expect, and the dev is using 1.23. And we know in production you would use n-1 or n-2. Here we are using n-1. Now let me see if I want to show you something else as well. Let me go to the GitHub notes. We have verified the deployment. We have also verified this service part. We have not seen, but we can write the same for the service as well. I will write svc here, and you see there is a service created for all the releases. Here is for dev, and here is for prod, and here is for stage. They are pretty much similar because they just have the difference in the naming, and they all of course are serving on different node port. That is what we understand. Now let's go back to browser and see if there is something else I want to show. Here are a few more things that you can test on your own, but at a high level, I have covered everything I wanted to cover. Now see, before I end this lecture, Helm provides advanced capabilities such as functions, pipelines, conditionals, loops, range with block, named templates, chart hooks, and more. And we have not discussed these things because whatever we have discussed is sufficient for the CKA exam and also to verify your production implementations. The concepts remain the same, but it's just with functions, name templates, chart hooks, and so on, you get additional bells and whistles. But what you have learned today is applicable in production, be it the upgrades and rollbacks. and be it different values.yamls for your different environments. That's a wrap for Helm. We now understand how Helm simplifies deployments, versioning, and multiple environment management. In the next session, we will move on to stateful sets, which are essential for managing stateful applications in Kubernetes. If you have any questions, feel free to ask them in the comment section and I will reply. If this helped, do consider liking, sharing, and subscribing. It will mean a lot to me. Thank you very much.